Guan Yu. I'm Adeline Goh, SB22048. My team and I are students of BSB 3113 Gene Technology. We were given a task to discuss current one research or case study on applying gene technology analysis with artificial intelligence AI in the food industry. Today, we will present a research article titled Artificial Intelligence in Food Biotechnology, Trends and Perspective. It examines the integration of CRISPR-Cas9 and AI in the food industry, enhancing crop resilience and nutritional value, addressing global food security challenges. However, it also raises ethical concerns, particularly in Malaysia, where issues of biodiversity and food sovereignty are paramount. Our presentation will focus on the use of CRISPR-Cas9 and AI in the food sector, focusing on its significance, principles, advantage, disadvantage, and ethical implications.
Assalamualaikum and hi everyone. My name is Nur Afrina Nurkabinti Asani with metric ID SB22110. So today, I'll quickly take you through the groundbreaking combination of the CRISPR-Cas9 and artificial intelligence in revolutionizing the food biotechnology. So let's start with the genome editing. AI is a game changer in analyzing the massive genomic datasets. It identifies the processed genetic targets, and CRISPR-Cas9 takes over to edit those targets with unparalleled accuracy. So this synergy accelerates the development of the genetically modified microbes or crops that meets the growing demands of the food productions. Next, we have a microbial engineering. CRISPR-Cas9 is used to engineer cell factories. Microbes like yeast and fungi is for precision fermentations. So with AI predicting the best genetic tweaks, we can drastically improve the yield and create the custom molecules for the food industry. AI tools such as AlphaFold also shine in enzymes development. By predicting the protein structures, AI helps guide CRISPR-Cas9 to make targeted edits that enhance the enzyme performance in food processing. So these steps save time and ensure that enzymes work efficiently in real-world conditions. And finally, AI excels at managing and interpreting the big data. It streamlines the decision-making by prioritizing the CRISPR-Cas9 edits based on the predicted models, ensuring that we make the most impactful changes in complex environment. Okay, I'm diving into how AI and CRISPR-Cas9 work together to revolutionize the gene editing. So first, let's talk about the AI roles in target identifications. So AI processes vast genomic datasets to pinpoint the specific DNA sequences that could be edited. So using machine learning, it predicts the most effective sites for the CRISPR-Cas9 interventions, while accounting for challenges like off-target effects and also the gene interactions. So it's like having a highly skilled navigator guiding the process. Next, we go onto the CRISPR-Cas9 roles in precision editing. So when AI identifies the targets, CRISPR-Cas9 acts as a molecular scissors, cutting and editing the DNA at the specific spots with incredible accuracy. So AI takes it a step further by stimulating the potential impact of these edits, ensuring the changes are both precise and meaningful. And the collaboration doesn't stop there. Through data integrations, AI helps predict the outcomes, optimize edits, and streamline the experiments. So this means we can improve the microbial yield, enhance enzymes efficiency, or even boost disease resistance in crop more effectively. And finally, there's a feedback loop for optimizations. AI learns from the experimental data generated by the CRISPR-Cas9, continuously refining its prediction and improving the editing processes over time. So in short, AI and CRISPR-Cas9 are a powerhouse duo, so blending computational intelligence with the molecular precisions to shape the future of biotechnology.
So we first go to advantages of applying CRISPR-Cas9 with AI in the food industry. So the first advantage is precision and efficiency. AI enhances the precision of CRISPR-Cas9 by predicting optimal target sites in the genome, minimizing off-target effects. This targeted approach allows for quicker development of crops that are more resilient to environment stresses such as drought or disease. Additionally, The efficiency gained through AI-driven gene editing can lead to reduced costs in research and development, while the last advantage will be innovation in food products. The combination of CRISPR-Cas9 and AI enables the creation of novel food products tailored to consumer preference, such as enhanced nutritional profiles. AI can help identify emerging trends in consumer behavior, allowing food producers to develop products that meet specific market demands. Additionally, the technology can facilitate the development of functional foods that offer health benefits beyond basic nutrition. While for the disadvantages of applying CRISPR-Cas9 with AI in the food industry, we're concerned about the data privacy and security. The extensive data collected during AI analysis can pose risk if not properly secured, potentially leading to breaches of sensitive genetic information. Concerns about data privacy can also extend to consumer information, raising ethical questions about how the data is used. Additionally, regulatory frameworks may not be fully equipped to handle the complexities of data privacy in the context. Well, last but not least, the disadvantage will be the ethical concerns. The use of gene editing raises ethical issues related to biodiversity and the potential monopolization of food resources by large corporations. There are concerns about the long-term ecological impacts of introducing genetically modified organisms into the environment. Additionally, the debate over food sovereignty highlights the need for inclusive discussions that consider the voices of local communities. So that's all for the advantages and disadvantages of applying CRISPR-Cas9 with AI in the food industry. So we will furthermore into the ethical concerns presented by Chloe with the following slide.
My name is Sao Hoi with student ID SB22068. I will discuss about the ethical issue that may arise from the application of CRISPR-Cas9 in Malaysia. The first ethical issue is that, is Malaysia ready for human genes editing? A regulatory, biosafety and biosecurity perspective. The ethical concern of CRISPR-Cas9 in Malaysia focusing on regulatory readiness, biosafety and biosecurity. Issues include the lack of comprehensive policy governing genomes editing, potential misuse of eugenics, and the challenge of aligning technology advancements with Malaysia's cultural, religious, and ethical value. It involves the regulatory frameworks that Malaysia currently lacks specific legal framework for gene editing, which complicates the governance of such technologies in a manner consistent with societal value. While guidelines exist for stem cell and cell-based therapies, they do not enough address the nuances of gene editing. Next, biosafety and biosecurity concerns. The potential risks associated with gene editing, including unintended consequences to human health and the environment, necessitates the development of comprehensive biosafety regulations that reflects the ethical consideration of Malaysian society. Lastly, public perception and ethical debates. The introduction of modern biotechnology in Malaysia has spread public debates over its uncertainties and risks. Aligning technological advancements with cultural and religious values require engaging with these public concerns to ensure that the development and application of gene editing technologies are ethically acceptable to the Malaysian populace. Second ethical issue in Malaysia is the CRISPR-Cas9 and He Jiankun case, an Islamic bioethics review using Maqasid al-Sharia and Qawaid Fiqhiyah. Ethical issues surrounding CRISPR-Cas9 in the context of Islamic bioethics, particularly focusing on the He Jiankun case. It identifies concerns about safety, efficiency, and misuse in gene-line editing, especially for non-therapeutic enhancements such as designer baby. From an Islamic perspective, gene-line editing may be permissible if aligned with Maqasid al-Sharia, objective of Islamic law, and Qawaid Fiqhiyah, jurisprudential principle provides address real therapeutic needs, ensure safety, and avoid harm. It highlights concerns about unequal access to the technology, which could deepen societal divides. Morally, it debates the permissibility of altering Allah's creations, especially for enhancements rather than therapy. Societal acceptance is questioned in contexts where altering human strengths may conflict with religion's principle or cultural norms. It advocates for decisions aligned with the higher objective of Islamic law and the preservation of human dignity. In conclusion, CRISPR-Cas9 is a groundbreaking gene editing technology that allows precise modification to DNA, offering transformative potential in medicines, agriculture, and research. Its promise to cure genetic disease, enhance crop resilience, and advance biotechnology. However, it raises ethical concerns such as safety risks, potential misuse, equity issue, and societal implications. Balancing innovative with ethical and regulatory consideration is essential for its responsible applications.